So I've been using Immutable Linux with my Basite custom image. I created my own custom Bootc image so I could run Neri and Noctalia. But I also started by adding all the tooling to the custom image. But after a while, this became quite difficult to manage because every time I needed to add some tool, I would need to rebuild the image. So I started using DistroBox a lot more, up to where I was just using DistroBox. And so I turned my Bootc image into a very minimal image, just for Neri and Noctalia and some other utilities that were more on the system level. And then I started using DistroBox by default. When I opened the terminal, it went straight into DistroBox. But then I listened to this podcast on the Fedora project where they interviewed James Harmison, and he told us that he uses everything baked into Bootc, including his configs. And so I was curious to try this myself. And so I decided to go back and put everything into Bootc again, but this time also add my configuration files instead of using Chemois. And so this video will be a lot about how to manage the life cycle for your Bootc image, how you can bake everything into the Bootc image but still test it beforehand, so you don't have to rebuild as frequently. And also, if you have to rebuild, how to make it build faster by using caching at the level of the image layers, but also at the level of the DNF or system packages level. So just a quick summary of this container versus host or DistroBox versus Bootc idea. So let's look at the pros and cons for DistroBox and Bootc. So for DistroBox, the clear pro is that it's mutable. It adds a mutable layer on top of your immutable OS. But it also has a few cons. For instance, it needs to be started manually, so it's not integrated into your shell directly. It might replace your shell if you use a script like we did before with the LTSH, which just replace your shell and started DistroBox directly. This was on stable 2 and 2.1 for the LTOS. This is no longer the case for stable 3. It also takes a little while to start on the first start. More than just opening a regular shell, right? And if you need to recreate it, it still takes some time reinstalling all the packages. So it's not that different from Bootc in that regard, but it does take a lot less time than Bootc does. And then we've got some Bootc pros. So there is a clean tooling integration with the system. The Bootc image is the system, right? And when the shell opens, that's it. It's open. It's just a regular system. But the cons for Bootc are obviously it's mostly immutable. So if you want to install anything, this is usually under /user, and user is not writable. Okay. It takes quite a long to rebuild, and even if you want to install some package and want to wait for it to rebuild, you'll still have to download the upgrade and apply it and reboot your machine. So there's quite an overhead to updating your system directly through Bootc. So you either prioritize DistroBox, and then you always have a mutable system and don't need to restart that much. And this was the logic that we adopted for the LTOS stable 2 and 2.1. Or you have to have some way of testing either your configs or the packages before migrating them into your own custom Bootc image, which is what we are now trying to do. So we are prioritizing the custom Bootc image. Everything will be at host level, except when we want to test something, in which case we'll use DistroBox, or maybe we just want to quickly install some Devil libraries, Devil packages for that we need for some headers to compile something, and we want to do that temporarily just to install some small tool. That's also a good use case. And also regarding configuration management, we are in the process of migrating most of our configs from the user home into /etc, right? When available. It's not always available, and it's not always the best approach. For instance, if you are dealing with NeoVim or Z configs, then you'll most likely want to keep those configs in your home, even if you can have a global init Lua for your NeoVim. You probably don't want to do that. I'm still debating myself whether to do that or not, but for now I am dropping these files directly in the user homes. And for this we'll be using systemd-tmpfiles, which is very simple to use. There was a bit of a drama with this tool in the past because of --purge, where users or some user lost all of his files in home. So I was very careful when looking at this, but it turns out it's a very simple tool to use, really. And so we will get into all of this today. I will begin by talking about the caching strategies that I implemented to speed up building the Bootc image. I'll also measure the time for different cases, so you can see exactly what the impact of different caching or chunking or not chunking will have in the building of our Bootc image. I'll talk a little bit about how /etc works for Bootc images, because it's a mutable directory, but it's a bit of a special directory. I'll talk about how you can do a simple setup with systemd-tmpfiles just to provision the config files for the user homes. And I'll also talk about how we migrated from Dotfiles to baked-in configs that are either system-wide or installed in the user homes with systemd-tmpfiles. And I will finish by talking about strategies that I use to test either the configs or the packages locally with local overrides through DistroBox, or by manually editing files under etc and making sure that the files are reverted to their original state so they can get overwritten when you Bootc upgrade. Okay, and so I'll talk about this today. It's a bit of a more advanced topic, and you know, this Bootc trend is something that it's fairly new technology. It's still developing, so there are many different ideas. For instance, I was thinking about how to manage secrets like Chimois does with encryption. You know, it integrates with age encryption, and we could do that as well with Bootc, just using regular system tooling. So I've been thinking about that as well, not for today's video, just to give you an idea of what I've been working on as well. And yeah, we will cover a bit of the process, and hopefully this will help you out deciding how to maintain your own custom Bootc image. You might want to fork the LTOS, you might want to use it directly, but I would fork it because it's the LTOS is a very personal image designed for me. I try to keep it as general as possible so other people can use it if they want, but it's mostly for my workflow. Okay, so if you want to, please feel free to fork the repo and, you know, test your own things. If you have any issues, anything you want to discuss, feel free to discuss it on our discussion forum on GitHub or on the issues, but please be aware that I might not try to solve the problem for you, because this is my own personal distro. Okay, so let's take a look at the caching strategies that I've been using here. these both work, and it took me a little long to get this to work. One of them was essentially inspired by what Bootc already does, but the other one was just, you know, regular image container image caching. And so one of the caching strategies that I use here is using a GitHub cache, as you can see here, through actions cache. And here we've got restore action, we build the image, and then we've got our save action over here. This is very similar to what Bootc already does. So essentially your build will run, and once it runs, we'll save var-tmp build a cache, and we give it a key with the hash for the current commit. So of course, if we do any change and commit again, this will have a different hash, but when we restore, we can set restore keys, which is prefix based. So if it doesn't find the exact cache for this particular run, let's say that run crashed and you are retrying, you know, it will use the specific cache. But if this fails, it will look for the latest cache with this prefix. So it will essentially just ignore the commit hash. And so this is how it works. And this cache under var-tmp build a cache is where the DNF cache will live. And also we are setting environment variables for when we install our tools with go install or cargo install, so that the cache for both go and cargo are stored under var cache. So this will also restore that cache in a way. So if we go into the container file, we'll see that we set opt cache equals 1 for DNF. This is the same strategy that Bootc uses on their image. And we also mount the /var cache and explicitly leave DNF5, although I believe this is redundant. It's just used so that you explicitly know that you will be expecting DNF cache on this stage, at least from what I understand. Please let me know in the comments if if I'm wrong here. And then I replaced the mounting approach for build scripts that the UBlue image template recommends, just because that wasn't working for caching for some reason. So not the GitHub cache that I just showed you, but for the container image cache. And so I replaced it, but we'll get to that. And so I use a single step for each of the scripts, because for image container or container image caching, this is important that you split this as much as you can. I think that it might even be beneficial to split this further into more scripts, so that, you know, the more steps you have cached, a little change won't need to rebuild. So for instance, if I need to add something to tooling, as you can see, I've got many DNF installs, go install, and all that. And if I just want to add a single install instruction here, then everything, the whole layer will not be cached, even if it's at the end of this script, because this is not the container file, it's a script, so it's a unit. And so splitting this further is better. If I were starting over, maybe I would do it that way and split it a bit further. But I'm fairly happy with how it is now. So at least it's important to me that I have control of how the caching hits or not. And so that brings us to the second caching approach, which is using a dash layers on builder, which is enabled by default. And as you can see, I'm running the command myself instead of using the action. It's just because I feel I have a little more control, but I believe you can use the action as well for builder. And so we use cache from and cache to. And in here, we are essentially just using the original registry and image name. So this will be the ghcr.io / datalabtech.tv / dltos - cache. Okay, so our image for cache will be called dash cache. Sometimes with Docker, you just use a tag :cache. Okay, but with builder, essentially it will need to use the tags for caching each layer, I believe. So what you set here is an actual image, not an image with a tag. Okay, and so for our container file, let's say that we didn't change the base install script, and we just changed tooling. So every step before tooling will be cached, and then when we get to tooling, we'll start building, but we'll have our DNF and Go and Rust cargo cache. Okay, so that's the whole idea. I also measured the runtime, the build time with several different cases. And one of the things that I considered was enabling or disabling the rechunker. And what rechunker does is try to decrease the size of the upgrade when the user runs Bootc upgrade. For instance, instead of downloading 6 gigs, it might just download 3.5 gigs or something like that. What this does essentially is just run rpm os3 compose build chunked OCI, and it just outputs a raw image locally for the GitHub action runner. And then when we push to the GitHub container registry, we use Scopio, and this is where we assign it one of the tags. So I experimented with the different test cases with different configurations to see how the cache would impact the build process, as well as how the rechunker would impact the build process, as well as the download size for the upgrades. And every time I needed to reset the cache, I essentially went into GitHub and I deleted this dltos cache image. Okay, as you can see, there are many hashes over here. These represent the cache, and I just would delete it by going to settings and delete this package. Okay, and I also went into actions, and you will find the caches over here. As you can see, I've got a bunch of caches here for Linux 64 bits builder, and this is the commit hash. Okay, and I will delete all of these as well. So I did 6 test cases. The first one was a standard image build with cache completely cleared, and this took 1 hour and 7 minutes, and the upgrade size, which is not very relevant here, was 3.5 gigs because it depends on what I had installed previously. So this should really be NA, but I just left it here for information purposes. Then I knew that the image was 100% cached. If I repeated the build process, everything should be cached. And this means that we are using 100% container image layer cache, because we will not be rebuilding any of the steps, and so we will not have the opportunity to hit the builder cache. And so this takes 23 minutes and 28 seconds, and the upgrade size was only 14 megabytes, and this is because it just changed essentially what is a bunch of metadata. Okay, the image was the same. Of course I ran RPM OS 3 upgrade from each test case to the next, right? And this is essentially what it downloaded in addition to after having applied the previous build. Then I simply remove the package from tooling, which is the second script that we run. The first one is the base to install the base system like Neri and Noctalia and a few tools. And tooling is to install the languages and command line software like LazyDocker or NeoVim or developer tools and all that. And so this took a little less than building the completely uncached image. It took 53 minutes. And one lesson we got from this is that our cargo installs were taking actually too long because they were always recompiling. So we ended up adding cache to cargo to the target directory, which we were missing. But this is not accounted on this experiment. We did that afterwards. And so once I upgraded the system, I downloaded 3.9 gigs. Then I re-added shell check, which is the package that I removed. So I essentially reset to the baseline, and this only took 24 minutes. So it means that it was as cached as this test case 2. So this is essentially equivalent time. And then it downloaded 3.6 gigs just because some stuff changed, right? Then I wanted to check how enabling or disabling the rechunker would impact the system. So I disabled it, reset the cache. So without any caching, if I ran the whole process, it would take 51 minutes. But it downloaded 6 gigs instead of 3.5, around 3. Or was the normal, so this downloaded more data. Of course, we also saved at least 16 minutes, but I think that this runs in the cloud, so it doesn't really affect me locally if it's day-to-day operations. Unless I'm working on it, trying to rebuild, it affects me, right? But if this is stable and it's just getting upstream updates from Basite, then I will it doesn't bother me, so I'd rather have a smaller download size. But if we with disabled rechunker and 100% cache, this only takes 7 minutes and a half to build. And as you can see, it also just takes downloads 0 bytes when trying to upgrade, because the rechunker surely changes some metadata, and so this is versus the 14 megabytes that we add here. So I essentially opted to keep the rechunker for now. Maybe in the future we'll switch this with Chunka, which it's being worked on. I haven't looked into it yet thoroughly, and I don't know if there is some negative impact since we are doing this upgrading based on RPM OS 3, and the rechunker that we use is based on our RPM OS 3 compose. And so I don't know if Chunka is easy to switch here or if it makes sense, but I think that we are evolving towards removing the package manager as the dependency. So I envision RPMs and devs will not matter in the future. I think that we will do everything based on images directly, and if we eventually get composable images like we do with dev containers, without having to rebuild an image, but just plug and play layers or blocks from different images into one operating system Bootc image, then we essentially have a cloud native way of combining packages, and we can even customize our own system with whatever, let's say, node version we want based on their official image, something like that. I don't know how good that is for, you know, security, but this example in particular, but I think the technology is developing in that direction. I don't quite went into detail with the Fedora Hummingbird project, but I think that they are prioritizing this idea from what I understand. So now let's talk about configuration management directly on Bootc, you know. And so first we need to understand two concepts. We need to understand how /etc is defined for Bootc, how it works, and we also need to understand how systemd-tmpfiles work. So first let's take a look at /etc, and this is a mutable directory. It's admin managed. You can set the etc transient option, which means that this directory will be mutable, but once you reboot, it will reset to its original factory configuration or the image defaults, you know. But this is not set by default, so this is false, and it's false on our image as well. So it essentially performs a three-way merge across upgrades, and it does this in the following way. So it has three steps. The first two steps refer to the /etc directory within the image. Okay, so we are not looking at the system etc directory as it is now. So it takes the new etc directory for the upcoming upgrade and takes that as the base, and then it runs a diff between the current and the previous etc directory and applies it to the new etc directory, and then we would have an up-to-date config based on the previous image and the current image. And then it takes locally modified files that are different from the default, and these defaults are tracked under user etc. So once you add files to /etc for your custom image, Bootc during its building process somewhere along the way copies these defaults to user etc, so it has a reference, because keep in mind /etc files are mutable, you can change them. And so it compares these files with the new version of etc to install, and files that have been modified, they will be retained, they will be kept. And this is why, for instance, when I test some change on my ZSH config, I will revert back to the original file before you know, actually committing that change, because I want to test it and then add a change to my custom Bootc image, and then rebuild and let the Bootc upgrade replace that file. You can control this and you can test locally without, as long as you make sure that the files revert to its original state. Okay, and this is how /etc works. It's a mutable directory, but there is a three-way merge operation that happens between upgrades. So by the way, this is how you know that you are on DLTOS, that your Bootc switch did apply the change. You can run just fast fetch and you'll get our up-to-date logo with the DLTOS stable or latest. You can use either stable or latest. Latest is just an image where I do small changes, like adding a package, nothing too major. I wouldn't recommend that you use testing, because that's where I'm refactoring heavily the image. That will not be usable. It's highly unstable. I just don't use unstable because, you know, I don't need another level here. But yeah, you can use DLT OS stable or latest, or you can fix one of the versions as well. And so let's take a look at systemd-tmpfiles. There is a man page for this called man-tmpfiles-d, and in here you'll find how to configure systemd-tmpfiles. You can either configure user tmpfiles or tmpfiles. These exist under etc, run, user local lib, user lib, and for the user tmpfiles you also get a directory on your home, on local share as well, config and local share, and you get also the global versions, the system-wide versions for this, which is the ones that we use under user share user tmpfiles d. In fact, if you ls user share user tmpfiles d, you'll find the files that we created here, and let's for instance take a look at one of them. For instance, for the NeoVim config, you'll find this over here, and this essentially means the C means that it will create this directory NeoVim if the directory doesn't exist. So if the directory exists and is empty, nothing is done. The directory actually needs to not exist for this to be copied over, and this %h maps to the user's home, and this is why you use user tmpfiles, otherwise this wouldn't be instanced. And we also don't use %u home %u, because otherwise root wouldn't work, wouldn't be covered by this. So %h will either map to /root or /home DLT or something like that. And so this is the destination. Then we got a few fields that I'm not using here, and we'll get to that in a second, although it's not very relevant here. And this is the source. So all the default configs for any applications that we cover here will be under user share, the name of the application /defaults. So if you go into user share and vim defaults, you'll find that we've got our init Lua and our Lua files in here, so we can actually check this way. Okay. And so just to clarify what these fields are, let's go into the man pages. In here you'll find all the types. C is one of the types, as you can see here, target to create. You get a cleanup age, so let's take a look at what this is. So you got mode. The mode is your regular octal mode for permissions, you know, user, group, and others, read, write, execute. And then we got the user and the group, and also we can get an age, because these files can get cleaned or deleted after some time. Of course, in this case, we are not using any cleanup age because we want to maintain the files, of course. But systemd-tmpfiles was originally created to manage temporary files, although I personally like to think of it as tmp for template, although there is not really any template language here beyond the config. The files themselves are not parsed. They are just files that you copy over. But I think that they should in fact do this rebranding in the future and just call it templates instead of TMP. I think that would serve this better and would not have to require any name change, because that would be, you know, a hassle. And so if you want to check other details about this, you'll find them here, but you'll find the legend, the captions for these fields over here as well, with some examples. For instance, let's say that we want to clean up run user from files that are over 10 days old, or your TMP directory, the original function for this, right? And so why use systemd-tmpfiles? Because if you are building your own custom Bootc image, and if you try to copy over to var home, first of all, you won't know the user at build time, okay? Let's say that you knew the user. If you copy it over here, it will not appear on final image because these are mutable directories and they are mounted elsewhere. Okay, I don't know all the details, but they are mounted elsewhere. So you wouldn't be able to do this anyway. One way we could think about doing this would be to use etc scale. Okay, and if we go in here, I think there are some hidden files. Okay, these are the default files that are copied to a user's home during user creation. But the problem is you will be installing Bootc, and during installation you will create your user, and you will only switch to my image, the LTOS, or your own custom image after you boot into Bootc. And so by that time you will have created your user. So the only real way to manage this that I know of is to use systemd-tmpfiles. You can check that systemd-tmpfiles setup is running for your user. Okay, it's installed on the user lib systemd user, and this is enabled globally. So when you essentially run sudo systemctl global enable that service, you will enable this for all users. That's what global means, not system-wide. System-wide wouldn't need any flag. And so this is enabled, and as you can see, it runs for the user. It creates, removes, and whatever boot means. So it does these operations according to the config. So if there's something to remove, it will remove them. If there's something to create, it will create. But really depends on the config. We also get a global one for the system. As you can see, there is no -- user here. And we also get a clean one, okay, which runs clean operations. So the cleanup, the 10 days cleanup, it will be run by this service. It runs periodically through this timer. So systemctl, this timers, let's see, this runs maybe every 24 hours, I think. Let's see if there is one for the user. But you really don't need to, care about this. Just know that once you switch to the LTOS custom image, you'll get your nvim config files, under here. And of course, once this is added, it won't get any more updates in the future. If you want it to update, then just delete the directory and reboot, or rerun the setup service, and this will be added back. This is by design. Of course, we don't want to mess with your homes. Maybe in the future I will migrate most of these configs to system-wide configs. It makes sense, but this is also information for you who are creating your own custom image, and if you want to do it this way, you can do it this way. One thing that I haven't integrated yet from Shimoa is secrets, but of course you can use stuff like the pass utility, I think, or something like this to manage your secrets, and I'm thinking about using something myself in this way. So now let's make a parallel between our previous repo for Shimoa.files and how we migrated this to the system, to the Bootc image directly. So this is a view of the relevant config files from the Dotfiles repo. There is a video about this on managing Linux configs like a pro, where I talk about how to use Shimoa for this. But of course this was short-lived, because now I'm trying to bake all of this into my Bootc image. But either way, not every Linux install is based on Bootc, so Shimoa still makes sense as a way to manage your .file. And I'm still using it just to manage some .files with secrets that I have. And so let's take a look at this. So .config, we had the bat config, a config for containers, which set the Docker Compose for Podman. We've got a DRM config, some environment variables, the kitty config, the Neri config. This is the local version, because we already provide a system-wide version even before we migrated this. We got an EOVim config. We've got a console config, which is a fallback console in case Kitty doesn't open due to some graphical issue. Sometimes when you open a game, you won't be able to open Kitty in parallel for some reason. When I use GameScope, we're golden, no problems there. But if you don't use GameScope, you'll hit into these problems. So I use console as a fallback because it doesn't have acceleration by default. So I provide a default config for this. There is one for Starship, one for the portals, one for Zed, the ZSH configs, and some configs that I no longer use. These were binaries. This never really worked. That's why I never really talked about it. Also, this was tried to fix NVIDIA sleep issues, but I still have them from time to time. And then we've got our Delta, which is a diff command line tool. I just use a custom theme. And then we've got our console profile and the Z profile and ZSH RC. And so a few of these I didn't need anymore, so I deleted them. You can read all about this in the blog post, link in the description. But this is how the configs ended up being moved to system-wide. Not all of them were made system-wide, but for those that were copied to etc., we got our bat config. And this needed to be accompanied by a bat conf for environment, because a lot of these utilities require that you set an environment variable that points to the config file. This is the case for bat, for DRM, and I believe for Starship as well. And so I've got my BC config. Also BC is one of these cases. We've got the containers config. We got the DRM config. This git config replaces the Delta theme config. The Neri, this is the global Neri config. It already existed before. We got our Starship config. We got our Kitty config, our Portals config, which is now specific to Neri, which is what it should have been from the beginning. We got our Z profile. We got our functions, which are under ZSH. Then we got our ZSHRC and the .d, because this file will load these scripts in order, and we cleaned up this a bit as well. And then for user configs, which means that are configs that are stored under user share app defaults, and will be copied to the user's home using systemd-tmpfiles. We've got a GameScope config that lets you set your keyboard layout. This is commented out by default, but if you need to set your keyboard on GameScope to something else that's not US, please uncomment this and just log out and log in, you'll be okay. We get the console defaults. We call it the LTOS profile now, and we deleted the other file that for SSH that we didn't really need. Then we got default user Neri config, which imports the system config and adds a few commented lines, so you can easily uncomment and set your keyboard layout, your monitor scaling, stuff like that. Then we got the NeoVim configs. This was just exactly the same as the ones that we provide on Chemois. And then we've got our user TMP files, which are the ones that set this up. So we copy them here. During image build, we'll be copying these files. And then we got our Z configuration. Okay. So we can take a look at these configurations and how they look like on our custom Bootc image repo. So most of our build scripts will be in here. our ZSH plugins are set in here just because we will be using Antidote to install this, but we will not provide Antidote by default, and so they are installed build time. There is no copy of ZSH plugins to the final configurations to keep them clean. You know, if you want to do this for your user, you are free to add it. And so our system files will get etc. and user, and so we'll get our configs in here. For instance, for the kitty config, you'll find it here. The global near config will be here. It's already existed. Just let me show you the environment variables. For instance, for bat we set bat config there. For BC there is also an argument. For this DRAM, these are very similar. Okay, and finally we also have user share, and we've got a bunch of configs. For instance, for NeoVim, we got the NeoVim configs over here, and these are defined. For instance, for NeoVim, they are defined on this NeoVim conf user TMP file. For Neri, we also got user config. So, for instance, the user config for Neri will look like something like this. It will include the system-wide config, and then we've got a few examples. If you want to start up applications that with our tray launch script, you can do it this way. You can disable the hotkey overlay. You can set your keyboard to something other than US. I use PT, for instance. You can set your output, and be sure to check which output identifier you need here. You can set scaling here. You can set custom layouts here. I use this in addition to the other three that are already provided. And so this is essentially how you manage your user configs, how you bake them in directly in Bootc. I also provide an interesting utility. So in here you'll find a just file with several commands, and I added a few commands in here, these diff commands. So if you want to check the differences between the configs on the repo and the configs that you've got installed in your user directory, this is currently just for the systemd-tmpfiles installed, but I will probably expand this to other files as well in the future. You can run this, okay, and it will show you what we did. For instance, for game scope, I uncommented the keyboard layout, so I will not be updating this, and I uncommented all of these lines and actually have a new rule in here for Emacs. I've been thinking about exploring org mode. It's unavoidable, right? I also have a few configs for Z that are not something that I would commit to the Bootc image, so they exist here. If for some reason I would want to update this version of the image, let's say that I want to update it with my Z config, I would be able to run just import Z user configs, and these will be copied over. And as you can see, settings has got the new changes now, and I could commit that or edit it more likely before committing it. Okay, and so these are a few utilities that I've added as well to our just file over here. And so let's say that you want to test one of your configs without committing, and adding it to your final Bootc image, so you don't want to have to rebuild without having tested it. So as you know, etc. will be immutable. So for instance, if I want to edit ZSHRC, I can enter this file, and let's say that I want to profile it, zmod load zsh zprof. Let's load the profiler, and then let's run the profiler. Say I did this, then I want to exec zsh, and I'll be running the profiler here. This is a very common operation. So now I might want to make sure that I go back to the original ZSHRC, I can diff with the version and the user, etc. As you can see, it detects that these two lines were changed. So I can very easily go into the shrc again and just delete these two lines and then diff, and as you can see, this is back to the original. So it will be, if I change it on the Bootc image, it will be override when I Bootc upgrade. Okay, so this is essentially how you run these types of operations. Also, if it's for a local config, you can edit, for instance, you can just clone the LTOS directory, and as you know, we've got our diff. Let's say that we are diffing nvim. There is nothing different in nvim. Let's say that I go into my nvim config under Lua plugins, let's say color theme, and let's say that I switch the Capuchin nvim theme with the Tokyo Night theme. Okay, and I save. Now if I just diff, I'll have this change, and I can copy this into the image by running import nvim user configs, and this will be fetched into the image. As you can see, one file changed. Currently I'm copying everything over, but in the future I'll use something like rsync, although these files are very small, but just to avoid copying files that are already up to date. And so this would be updated. I don't want to change it right now, so I'm going to put it back, and it was actually switching to Tokyo Night, but if I do it again, it is now correctly on Capuchin Mocha. Okay, and so that's how you test your configs before, you know, updating your image. And keep in mind, whenever you feel the urge to just do a little update on your custom Bootc image, don't do it. Test it on your system, because it will take quite a long time to update to rebuild the image and upgrade the system, and it will completely break your flow. And this was one of my original problems. This is what led me to run everything in DistroBox instead, but that just doesn't need to be the case. It's not a requirement. You can still test it and then commit to your image later. Then, if you want to test a package, the best way to do so is to just install the DistroBox that we provide for the LTOS. Okay, this will just install basic ZSH configs. It will point to your system configs, read only. And then it will install NeoVim and a bunch of command line utilities just to make this consistent with what you use. And once you can create it by running DistroBox DLTOS, and you can run replace if you want to replace an already existing image. But once you do that, it will be available at all times, and you can just run DistroBox enter DLTOS. And this is the extra lag that I was talking about. If you use DistroBox by default on the first run, you'll always get this, and you'll get fast fetch for the operating system within DistroBox, not your real host system. I mean, this is not that relevant, but I like the details, you know. I'm one of those persons that needs the beautiful things, but also functional things. And so I'm in the package. Let's say that I wanted to test the pass command, so I can run dnf install pass, and this is actually one of the things that I'm about to test among other similar utilities. And so now we've got a pass command that works as a password manager for Unix command line. Okay, and let's say that I exit the DistroBox. There is no pass command here. Okay, but once I'm in DistroBox, I can simply export the bin for the pass command. Okay, DistroBox export --bin which path. This will give you the path, and once you do that, you'll have paths available on your host system, and you can go back to your host system. Okay, and if you don't want it again, you can just DistroBox export with -d. This will delete this from the host, and the command is no longer available. You can also, if you want to install desktop apps, you can export something like apps Emacs. This will add an entry to your menu. So I currently have Emacs installed, as you can see. But if I do this, okay, I don't have it installed on the DistroBox, but if I did this, I would have two entries, one for the DistroBox version, of course. So you can test both desktop apps and command line apps from the DistroBox, export them to your host system. Once you are satisfied and want to keep the app, you can copy the DNF install into your build script for your custom Bootc image, and in the next build you'll get that into your host system, and you can just DistroBox delete the exported app or binary, and that's that. Okay, and this is how I test any change that I want to do to my custom image without, you know, wasting the whole afternoon rebuilding images, and just to discover that, oops, this is not the tool that I want, or oops, the config was wrong. And believe me, I did that a lot of times, and I'm trying to save you time here. So resist doing this if you have the urge to edit directly on your Bootc image, because it's something very simple. I can almost guarantee you 90% of the times you will get some bug that you did not expect and end up wasting a few hours on it instead of working on what you were working on. So instead, use DistroBox to test this, or edit directly the configs on your home, on your etc. For your system. And once you are ready to go back to the image, just reset to the original config, upgrade to the latest version, and you'll get the configs tracked by the image from that time onward. Okay. Okay guys, that's it for today. Hopefully you found this video interesting. I know that many people have been watching my Linux videos, and I guess I've got more views on those videos because this is a topic that I really love. I've been working with Linux since the 90s, and it's been always a passion of mine. Also, BSD was at some point a real passion. I was a FreeBSD guy and an OpenBSD guy. I at one point ran my all my services before Gmail was a thing. I used to run my own email server on OpenBSD, and I used PF, which is their firewall, to manage everything. I had a transparent proxy for caching for the whole home. I had got a bunch of cool stuff, you know. And this was back in the early 2000s. Then I went back to Windows as my desktop because I wanted to play games and not have to think about it. But now that Bazite, you know, can play games quite well, there is almost no difference to using Windows at this point. It still requires some tuning, but it's very minimal. So for me, since I'm such a Linux lover and I love to tinker and program as well and all that, this is convergence of good stuff in one system. Also, this Bootc thing is beautiful, and we are moving towards a very, very interesting time in the open source community, in the Linux community. And I'm very excited to see what's coming next with Chunka, and maybe in the future with composable images. Maybe we can, distribute packages through some system like that. I think we need a way to have composable images rather than simply using a container file. Of course, that's one kind of composition, but I think we need something that we can just run in the command line directly, or maybe it already exists with Builder and I just don't know about it. But I think that's where we are walking towards, and it's been fun. So hopefully I'll see you next time with a new podcast episode. It should be about digital freedom. I haven't started working on it yet, but you know, I've been suffering through all these authoritarian dystopian laws that they are trying to pass. So I'm more than aware of the direction we are going, and I will be speaking in favor of digital freedom in my next podcast. You know, freedom with responsibility always, but not with control from governments or big tech. So I'll see you next time, guys. Hopefully, until next time, you keep doing work on your systems.